Bam! Welcome, everybody. Here we are, additional practice 3-6. This should be page 65 and 66 in your packet. So, hope you're doing great today. Let's keep on with our qualitative graphs. Again, sometimes we're going to sketch them. Sometimes we're going to have to pick out which one matches the story they give us. And that's what we got here on question number 1. So let's, as we read through it, think about the intervals. How many is it going to have? And what should be going on? An airplane ascends for 20 minutes. There's your first interval. It flies at that cruising altitude for an hour. An hour is longer than 20 minutes. So think about that. Interval's got to be a lot longer. Then it descends for 15 minutes. Okay? That one's going to be about the same distance on our x values as the first one was. Which graph shows that? Okay? Not really liking that one. Down, over, down. No, don't like that one. I think we like this one, right? Here the plane ascends, right, for, 20 minutes. Then we cruise at that altitude for a lot longer, and then we descend. So, yeah, we like letter C for number 1. Number 2, which of the following description best matches this graph? Okay, so this is our distance from home and time. So, are we starting at home? If we were here, we'd be starting at home. We're starting at some number, right? Some distance away from home. I don't know if this is 10 or 15 or whatever it is, right? And it looks like our distance from home is staying the same for a while, and then it's decreasing, okay? So I haven't even looked at any of these answer choices. I'm just reading the graph. Distance stayed the same for a while, and then it decreased. And do we end up at home? We do. Okay. Gail is at a friend's house for a few hours. She then walks home. Okay, that sounds like it could be it. Gail is at her house. She then walks to her friend's house. No, I don't think that's right. Gail is at her house and does not leave. No. Gail is at a friend's house for a few hours. She then walks to another friend's house further away from her home. I like the starting of that, but no, if she walks further away, right, her distance would increase, right? So we actually like letter A on this one. Okay? Write a situation to match the given graph. So guys, if you want to come up with your own story for this, you can, right? But what it has to stay true is as time increases, right, what's happening to the number of cars? Well, they're increasing for some period of time, then they're decreasing, and then they're increasing again. Now, they've given this to me in hours, right? So this isn't like days or months or years. So we can't have like some kind of crazy long story here. Maybe this is at some kind of a parking garage, right? And the number of cars are increasing in the morning as, the parking garage is filling up with everybody, coming in to start their day. And then slowly throughout the day, cars leave. They're leaving to go to lunch, or they're leaving because they only work, a couple hours, or who knows what. And then maybe the parking lot fills back up in the evening. Maybe there's some kind of an event that's going on, and maybe the parking garage fills back up. That could be my scenario or my story to match that graph. Does that sound okay for you guys? Yeah, I don't think that's too bad. All right, here we go. Now we get to sketch. This is probably one of my favorite things to do. On a given day, the outdoor temperature was cool in the early morning. Okay? Telling us that's kind of where we're going to start. Then it rose steadily until noon. All right? So it rose steadily until noon. From noon until the afternoon, the temperature was constant. All right? Then the temperature dropped steadily for a few hours and then remained constant. All right, sketch a graph. So, guys, I've color-coded all of the different intervals I think we're going to have. Okay? So the temperature is going to start somewhere. Again, it's cooler, so I'm thinking we should probably start somewhere lower here. I don't know that we're going to start here. Maybe we'll start about here, okay? And it rose steadily until noon. So maybe it goes steadily until noon, okay? Then from noon until the afternoon, it remains constant. So now our temperature is constant for a while. All right? Then it drops steadily for a few hours. Okay? Again, it doesn't say if it is colder or warmer than when we started. If we knew that, we would know where to stop this line. But it doesn't tell me that, so I think we're okay here. And then it remains constant for a few hours. So these are like the overnight hours, right? The temperature was constant, okay? So I think if we've got that shape right there, I think we are A-okay and doing great. Okay? Any questions? Anybody? Come on. No questions? All right. Write a scenario to match the graph. Again, we're talking about the height in feet, the time in years. Okay? Height, feet, time, years. So maybe this is the height of a tree over time, right? Or a plant, a flower, a whatever, right? So as the years go on, the height increases. Okay? That's what your story needs to have. As the price of a certain car increases, fewer cars are sold. Sketch a graph that shows that relationship. Okay, so remember, number of cars sold, cost. As the price increases, okay, fewer cars are sold. So as this increases, less of these are sold. So meaning when the price isn't very high, we're going to sell a lot of them, right? As the price increases, the number of cars decreases. So yeah, we've got to have a line that looks something like this, okay? All right. Here we go. Man, we're just cruising right through this here. A company is reviewing its sales for a given year. In the first 2 months, sales went up steadily. The first 2 months, sales went up steadily every month. Over the next 4 months, sales declined steadily. Okay? In the next 3, they were constant, and then they increased steadily during the last 3. Okay? How many little tick marks do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Wouldn't it be nice if we had 10, 11, 12? Watch this. 10, 11, 12. Look, I just made my graph a little bit longer. Now every one of these can represent a month, okay? And I think that might make our lives easier. In the first 2 months, sales went up steadily, okay? So here's 1 month, 2 months. So sales go up steadily for 2 months, okay? Then in the next 4, they declined steadily. So from 1, 2, 3, over the next 4 months, they declined steadily. All right. The next 3, we were constant. So 1, 2, 3. Right. Sales are constant. And then they increased steadily during the last 1, 2, 3 months. Oh, no, we don't want to erase. No eraser. All right. Then increased steadily. There you go. So increase, decrease, constant, increase. That's what we're looking for there. Again, if you made your lines, taller, okay, that's fine, but it's going to take that general shape that we have there. Okay. Alrighty. Here we go. I'm given a scenario here. I think I've got to pick it out. We bike 6.5 miles from home to a friend's house. Okay, again, this is distance in miles, time in hours. On the way, we stop at a store that's 2.25 miles from home. So we go a little bit from home, we stop. All right, then we probably go on to our friends. You bike at a speed of 7 miles an hour. Which graph describes the total distance you biked? Okay. Well, this one says we started at 0 miles away from home. We biked for a little bit, then things were constant, and then we came back home. This one says we started 4 miles away from home. No. I think it's got to be one of these two here. All right. They wouldn't give me these numbers if they didn't want me to use them, folks. So we're 6.5 miles from a friend's house. So eventually we're going to get there. Before we get there, though, we go 2 miles, right? And then we stop at a store. So look at your x's. I'm sorry, look at your y variables. Look at your numbers here. 0, 2, 4, 6. Okay. And 2 miles, we stop at a store, and 6 miles, we're at our friend's house, right? We got to pick this graph here because look, our constant interval is at 2. That's where the store is, 2.25, right? We're there for some time, and then we bike to our friend's house, right? Who's 6 miles away. 2, 4, 6, all the way up here at the top of the graph, okay? So we like letter C there. Nope, I can't scroll up anymore. In one portion of a bike race, Marco bikes at a constant speed of 9 miles an hour. Describe the graph that represents the relationship between distance and time during that portion of a race, okay? So he bikes at a constant speed of 9 miles per hour. So if we're going to describe the relationship there between time and distance, time is the x variable, okay? Distance is the y variable. So as time increases, what's happening to distance? It's increasing as well, right? It's going to look like, interval number 1 here. All right? So if we're thinking about it, hey, as time increases, distance is going to increase. So it's going to look like that. Okay, so guys, there was our additional practice for 3-6. Hopefully you're getting more comfortable with this. Mr. Noel and we have tons of practice on this, be it Desmos activities or some other ones as well. So your goal is to get more comfortable with the relationship that we see between our two quantities so that we can do a nice job of graphing stuff. All right? I'll see you guys.